what does Grady Booch have to say about a software architecture these days? Okay, I guess we're on part 4. If you missed part 1 through 3, you can go back and look at my other videos. But yeah, we're gonna the tech support. Yeah, they're coming out. They're gonna close it up right and left. Get them confused. Okay, so we're gonna continue on where we left off, with me ranting about Grady Booch and calling out some of his stuff and agreeing with some of his stuff. So here we go.
Decisions. What are the decisions that shape my system? As an architect, that's what I'm doing. As the project manager or whatever, I'm also
Okay,
architecture. Architecture represents the set of significant design decisions that shape the form and function of a system, where significant is measured by cost of change. So software
significant measured by cost of change. Exactly. That's the main problem we're having, is changing this stuff, fixing it, understanding it, so other people can be onboarded effectively into this project, understanding what's going on, diagnosing how it's doing it now, what needs to be done, having a bridge to get there, like extending it. Yes, this is the main problem. Not creating it, not designing it, modifying and changing it. Like realizing there's another one. When do you give up? When do you give up on your grand architecture plan and say, okay, this isn't working? You've obviously missed something here. You're gonna move on to something more realistic, or take a chunk at a time, something different, some different plans. And this is where most projects fail, because no one knows how to do this, because we're working on human problems that haven't been solved yet. There might be a reason why they haven't been solved yet. It's because they're hard to do, or they're obtuse, or there's too many moving parts, or too many things it wants to do at the same time, or there's too many efforts coming in. It wants to be all things, all people, Swiss Army knife, and nobody uses it because it's too bulky to fit in your pocket anymore. That kind of stuff.
For architecture, an architect has this horrible emotional baggage around it. So think of it as,
for good reason. I talked about that last time, because there's been a lot of these guys who've used these UML, because Grady Booch told them, all you got to do is do a UML diagram, and the software developers can take it from there. It's like, no.
Decisions. What are the decisions that shape my system? As an architect,
well, not just the decisions. Like, what is it supposed to do? What techniques are you applying to this problem? There are many ways of addressing some issue. We can make, okay, like one of the guys I worked for a long time was like, when are we gonna have his wife asked me, when are we gonna have a robot to clean the bathrooms? I'm like, you probably won't ever see that. When we have a humanoid robot that's can do all the things, we probably won't see that. What's more likely is to have a bathroom that's designed to be self-cleaning. Wouldn't that make more sense? With parts that are all interchangeable and standardized and stuff, instead of a humanoid robot trying to get in there and all these different weird angles and stuff, wouldn't it make more sense to have, hey, this is your new bathroom. This is it's going to be set up for self-cleaning, if that's really important, like for hospitals or something like that. I mean, homes, I just don't know if you're ever going to see that. It's just going to be, then you have to have something to fix the robot, because it's going to mess up. It's just, this is how things are.
That's what I'm doing. As the project manager or whatever, I'm also about making decisions. But one subtle difference is that it's no longer just the decisions about the shape of the software, but it's the shape of the system itself, where it embodies itself in the physical world, where the other systems and humans themselves as well.
Yeah, where the rubber meets the road, where actually people use the system. What are you talking about, man? See, a lot of the stuff that Booch and these guys drive me crazy, except for Alan Kay. So there's Yinko doesn't do this. Alan Kay doesn't do this. They are very flowery with their language, and they don't explain what they mean. They have a pretty good idea what they mean, but they're using a gish gallop. They're just running along and just not explaining, what did you just mean by that? What are you talking about, man? And as I've listened, I've only listened to this guy a couple times. He just continues to do this. So it's like, well, you want to know? You gotta hire me. You gotta hire IBM. We got a team to get together to get a course so you can take. It's like, Jesus Christ, can you just explain what you're talking about? Is it really that complicated? Well, maybe I'm not gonna be able to take your system if it's that complex that you can't even explain in simple terms. Because every expert I've found, everybody that I've known that actually knows what the fuck they're talking about, can break it down in the smallest, simplest terms. And but if they don't have that, means he's still confused. He's trying to generalize something like human knowledge or human problem space. You can't do that. That's why you have to have individual people who get down to the gritty details of what we're actually doing for people. No, we're just going to do a UML diagram and do a prompt with an AI tool. They'll solve it. It's like, no, it's not. No, it's not, because you're going to hand it over to your customers. And here it is, and they're going to go, yeah, but we forgot about this part and do this thing over here, or this isn't working, and you're going to go try and prompt the thing. Oh, could you fix this part? And it's going to go, yeah, right. It's not there yet. You're going to have a human in the loop. I know.
That's what it is. It's all about decision process.
And have you seen this role change?
Right. Human decisions about human problems to the human space, not UML diagrams. We're going to generalize and abstract this concept. It's like, no, I don't want to abstract. I want to know all the things to do it the way I want to do it. Have you met humans? They like things in a particular way.
Did you see a golden age of companies?
And they're willing to pay for it. If you got it, if you got something that's going to fix it better, cheaper, faster, more fun, prettier, nicer, smells better. This is not rocket science, but you can't just automate all that shit away. You can't prompt your way through that.
Where they were employing software architects that were empowering them to churn out design. I'm seeing a bit less of this. I'm curious.
Yeah, because it failed. It was a bad idea. It was kayfabe already to begin with. And it was this whole UML diagram. Like, oh yeah, all you do is put some lines and pictures together, and those engineers will figure it out. It's like, no, man, that's not how this works.
Are you seeing something similar? Is this just a bubble that we're seeing? Just because you seem to embedded in a lot of different companies.
It's your companies like Grady Booch selling these courses and stuff. Yeah, it's a bubble. People trying to figure out ways of fixing problems and making things work better, cheaper, faster, more fun. That's a human thing. That's a person, people. The machine's never going to do that.
There's another soundbite I'll give you, which is that the entire history of software
engineering, on their own, directed by humans, yes, but not on their own. Come on, stop.
Is one of rising levels of abstraction. So what we're seeing here is the rise of another level of abstractions.
Right, you complained about it a little while ago, but now you're talking that's a good thing. So which is this? Which is it?
It gives us all these extraordinarily powerful frameworks from which I can build systems, in which, as I alluded to, the architectural decisions that were front and center for us back then are now embodied in these. So now becomes a decision. What cloud service do I use? What messaging system do I use? What platform do I use? That's the decision.
Yeah, who wants to rewrite that stuff? I think I already talked about this.
It has a lot of economic decisions and not just
have a review.
Not just software kinds of decisions associated with it. So I think the role of the architect.
It's all economics, man. We don't have unlimited time like a fellow at IBM does. We don't have unlimited time to get these things done, and it's damn crazy that we can even get them done in the time limits that we're given. You got 6 months, or you just lost your job. You have 3 months. What can you come up with? What can you build to make this thing, to show somebody to get to the next thing? What do you think this is? Like, what are you talking about? This purist, like, software development where there's no customers, no people involved. You're just writing code for the sake of code. Like, what are you talking about, guy? This is where it gets frustrating.
Because now I'm dealing with systemic problems, not just software problems themselves.
Software problems are systemic. I've already covered this. Or this thing jumped back for some reason. I don't know. It's Google software. I'm sure they got some real geniuses working over there. Let you oh yeah, you don't want to go back here. Oh, okay, your computer went to sleep for 5 seconds. Oh no, we're gonna jump around now. Okay, keep going.
Have you heard about the role called solutions architect? I think it was created maybe 10 years ago. Yeah, and it's about people who are doing cloud architecture. It's fascinating. It's a role specific to the cloud. Right.
No, it's not. No, they were using this in a general purpose kind of way, and they made it seem like, oh, I'm an architect. Oh, major big deal. I know all the architects, the cloud architect stuff, and I know all the back end. But I was like, no, you don't. You just have some ideas about how to fix stuff, and you got it promoted up the ranks, and you know that by putting this label after your end, you're going to get another $50K a year, and 55K bonus, and you're going to get sniped off by Google because you're an architect. Okay, whatever.
And as you said, they make economic decisions. What services do I use? Do I use AWS, GCP?
It's all economic, man. All this stuff is economic. What is it? Why is this a bad thing? Had the companies getting acquired. That's economic. I mean, why is this? There's a lot of things in software. It's used to be kind of taken for granted. It's like, yeah, man. By the way, I don't know if you knew this. We're taking people's jobs. Like, that was what we're doing with software. We're taking people's jobs away. You don't need to have helicopter pilots anymore. You can have a drone that runs software that does all the moves and everything that a helicopter pilot would be doing for doing the camera shots that you want. You don't have to hire helicopters anymore. Yeah, we took one of those guys' jobs away. They were too expensive anyway. We weren't accessible. So, but now people are like, I don't need helicopter guy. He's very dangerous, and it costs. I can buy 5 drones for 1 flight. Like, what?
Do I use EC2 or do I use another service?
Yeah, and that's why it's a systemic issue. You generally, if you're a startup, you're going to hire somebody who's done that before, who knows where the skeletons are buried, who knows, what the cost of these things are.
You're gonna do so you're gonna buy something. So you're gonna pay somebody else pay for it. Somebody else to pay for these things. Going down these decision trees. They have to. This is also a skill set. This is also architect. What do you think you're doing with these libraries or platforms, or what are you doing with Android or iOS or web? What are you talking about? What is it's on the cloud just because it's on somebody else's computer that makes it different? It's so weird. The way these guys talk about this stuff is so strange.
And so that's,
you would think that if someone like Grady Booch has been around as long as I have, maybe a little bit longer, would see that these things are not these buzzwords. They're just computers, just little processors that take data in and put data out. And it's just our cleverness, right? Our cleverness that can arrange these things in a particular way that allows this valuable problems to be solved for humans.
You'll hire those kind of folks because they'll accelerate you because they've made those decisions and they sort of know when the
well, yeah. But these things are ongoing, dude. It's not like there's one and done. What is it? What are you talking about, man? And you're talking about 250 services at Amazon that are constantly changing, modifying, upgrading, updating, deprecating, deleting. Oh, you're just gonna hire somebody that's already gone through that? It's constantly going on all the time. This is why we do need some AI tools to manage this complexity. I have a question though. Is that 250 services really? Is that how many we need? It seems like maybe those are one-offs for vertically integrated companies who are locked into the Amazon eco chamber.
So shape of what you're building now, what decisions next make sense. And they are systemic decisions because they have economic and long-term associated.
It's all economic. My God, this is all economic. Technology is just a side tool for these economic issues. Why is it such a? It's like it's a side issue. It's like this is a side. So if we didn't have the economics, we'd have all these problems. What do you think is going on here, man? I don't know. These IBM fellows. I mean, did they ever actually? I mean, he said he had a business. He was going through buyouts and acquiring companies. But does he really like understand what you're doing with this stuff? Like, I mean. It's bizarre. I can't. The way the guy talks, I can't tell if he's like doing sales pitches or. It's very odd. I'm just saying, he's like, what are you talking about, man?
Consequences to them.
One thing when it comes up with software architecture is migrations. I do notice that most large companies are being hurt by long-running migrations. And these migrations usually happen thanks to software architecture changing, for example, from going from monolith to microservices, or changing technologies, for example, going from Node to Go, or upgrading major version of frameworks, for example, one version of Angular to the other one. How do you think software architecture and migrations are connected? And
that's just the main issue. This is what updating, extending, improving part. It's always a pain in the dick. Why wasn't this thought out ahead of time? We're just kind of like, oh, we can do it now. Okay, we can put this together now. Now it's done. And then we used to be this concept of done. Like when Grady Booch and I came up, there was this done. You ship it. It has to be going on tape. You mail it out to people. It wasn't on the internet. There was no downloads. There was no BBSs. I mean, there were, but people didn't know how to use them. They didn't know what a modem was. It was too complicated. So they had floppies on disks. And every time you had a software update, it would be 3 months, 6 months. And it'd be lots of time in between to collect the data and all the bug reports and all those things and make all the changes and updates and everything and send it out again. Months, not days, not hours, not minutes, months. And it's really difficult, I think, for Grady Booch and other people like him to understand, like, hey, man, this shit's never fucking done. And he's like, you just kill it. No, you don't kill it. It's just abandoned. Nobody uses your stuff anymore. There's a new thing. A new drone came out. A new drone company came out. And the DJI is nothing anymore. In other words, the DJI software just slowly just stops being used.
And why do you think software migrations are just so darn hard? And
because they don't think about it. And there wasn't planned ahead. This wasn't part of the process. Extending, modifying, understanding, not part of the program. They were just trying to get the product out long enough to stay afloat so they could get their IPO. Not how do we update it 6 months from now? Or how do we do migrations in the most efficient way that makes it make sense? It's understandable, usable, painless. That's not part of it.
They don't seem to be going.
They've already got paid by that point. This is why these computers, the way they are, they're based on this Linux stuff. This is like computers 1.0. all this stuff, even though it's amazing, does all kinds of crazy, cool shit, whatever. This is still, we haven't seen the revolution yet. And Alan Kay's right. We haven't seen the revolution yet because it's the way we think about this stuff. It's still left over from the crufty tube-based technology batch processing days, and we're so beyond that. But these devices, they just haven't. The devices have ripped past what are our software tools. These software tools are from the 70s. It's bad.
Going away.
They are. Migrations will plague us until the heat death of the cosmos.
No, that's not true, sir. See, this is the kind of shit, man. This is the kind of shit, Grady Booch. This is the kind of shit that makes me pissed off, because you're basically telling people it's impossible. And you're a maven of the industry, a well-known creator of UML, and you're telling people it's going to be impossible to fix this problem, really? Is that what you're telling us? I find that's very specious, sir.
I believe,
They're just
because
really
you're always building economically viable software, but then the tech
Right. If certain other types of software becomes more economically viable, we'll start writing it with that. So what are you talking about, man?
technology is
This guy talks out his ass a lot. For being so smart, well-respected, maybe, this guy talks a lot of his ass. And I'm surprised no one else points this shit out, because they're like, oh, he's just very well known and well-respected. He's an IBM fellow,
changing out from under you that compels you to consider migrating. Consider the
It's constant, man. What are you talking about?
migration from monoliths from the 60s, 70s, 80s, till all of a sudden economically we had mini computers and now distributed systems. You're still not going to use an iPhone and put everything up in a mainframe, but those changes compel you to consider.
What do you mean? That's what we have now. It's just a local computer or some computer for somewhere else. This is not magic. It's in the cloud. It's just another computer somewhere else. Why does he talk like this? It's so weird. It's like, I got this touch of the tisms. This guy definitely does too. It's like, I think we get too focused in on what the machine's doing, and it's like, that's just an implementation detail. It's just what the system's doing and how it operates is more important than the system that it's running on. It's like, yes, I get it. I love it. It's great, amazing. I gotta get into it. But we have to really think about the bigger picture. It's like, if there's some better way to do this better, economically more viable, if we're putting it on a mainframe and putting it over there on a chicken coop, we're going to put it in the chicken coop. What are you talking about?
An architecture that better balances where the processing takes place. If all of a sudden I can begin to do edge inferencing on my devices, that's going to be something that's going to change architecture.
What the fuck is edge inferencing? What are you talking about, man?
As well. So there are always these changes, both in the hardware as well as societal changes, if you will, that impact the.
If you will, societal changes. Well, this guy is going off in like 65 different directions, gish galloping, open loops. This is very much marketing blurb shit, man. Okay, let's keep
structure
going.
Of my systems that are the forces that compel me to do this migration. But why is it hard?
Compel me. You mean the customer issues that have to be resolved because we don't have a way to upgrade these systems easily because nobody's thought about that? We just have a system breakdown and complexity and how to arrange your things, but not how to fix it, update it, understand it better, make it so it's easy to fix and find where problems are, monitor it. Nah, this is a new language. I'm gonna go straight from UML to the code. It's the Booch.
Well, another soundbite I'll give you is that the code is the truth, but the code is not the whole truth. There is so much.
Oh my God. This is the kind of shit they have an IBM fellow quoting. The code is the truth, but it's not the whole truth. Really? Did anybody think it was the whole truth? Did anybody think? Booch. Did anybody think it was the whole truth? Sir, what are you talking about, man?
That is outside of the code that represents design decisions, their rationale, why I chose this versus.
Yes, most of the stuff that you do in these software is tacit knowledge held in people's heads, and the businesses that are run by these MBA faggots and Harvard dickheads, man, they don't fucking care about any of this shit. They just want to know economic issues. How much head count? How much is this going to cost me? How can I ship it to the most customers for the highest price and the lowest cost to me? This is what are you talking about, IBM fellow? Dude, this guy, do people really respect this guy?
is why I didn't choose that. Subtle things as to why did I name things this way, because of its impact is long misunderstood. And so while the code may be the truth, the problem with moving migrations is that you lose, there's a loss of information, and it's difficult to try to recreate those design decisions just from the code. The people who wrote that initial code, you're trying to...
No shit, Dick Tracy. That's why the tacit knowledge, and no one talks about this. This is the most important part, by the way. I hate to tell you, is this tacit knowledge stuff. And these business people like want to just replace everybody as a replaceable cog, and they think that this AI tools are going to help them with this stuff. No, you are quit promoting this crap to get rid of people. Just quit it, Booch. Stop.
To move, they probably cashed out, or they've died, or some combination of. And so you
or got pushed out, or we're accused of something, sexual impropriety. What do you think these? Or somebody just got greedy and they just knew how to take it over and was more socially adept. Booch, come to reality, buddy.
You don't really know why those decisions were made.
Correct. That's why it's really important to keep people around, because that's where most of the stuff's at, and you're never going to get rid of it, man. Because it's somebody's insight to human problems, and you have to care about people. I know, Booch, I know. You have to care about people more than the code. There's like, he seems to care about the code way more than people, because he's being very casual and dismissive about what happens to these founders at these companies. They're all kicked out, man. Why? Well, because the NBA guys come in and just, oh, we got it from here. Thanks for finding a problem that needs a solution that we can charge for. We can take it from here, guy. And then they get these problems like, how do we extend this thing? How do we fix it? How do we do a migration of a database?
And so you're working a little bit in the dark.
Yeah,
a little bit in the dark, yeah. But you turn the lights off, man. You turn the lights off. You covered up the windows. And you kicked everybody out. Now you're in the dark. But who put you there? You kicked everybody out. You're like, oh, I'm alone in the dark.
You're mentioning people have died, and I don't think we usually think about that, but
they're not dying. They're getting pushed out and fired and accused and like weaseled and swindled and cheated. Come on, man. These guys are like, no, it's the computer industry. It's just pure logic. We do everything that's logical in the computer industry. We don't know anything that's illogical or anything, or devious or underhanded or corrupt or criminal.
I guess when you're thinking about systems that are 40, 50 years old.
He's trying to buy a system. Dude, this is elbows, just we're full contact sport, blood sport. What do you think this is? Did these people just get here? It's like, oh, I'm a computer engineer. We do everything by the book. It's like, dude.
Is the reality of some of them.
What will the Linux kernel look like when Linus eventually retires? So how...
hopefully the Linux will be done and will be over that system by then. And the fact that one guy's carrying this thing is a testament to how corrupt this whole thing is. And it's just ripe for someone to take it over and slish it aside.
How will it drift? Because he has provided a...
How will it drift? Like how it's drifted so far. Just a bunch of grifters and hucksters and liars, cheaters, stealers, and MK Ultra advocates and government grifters. It's just been bad. It's been a mess.
A firm and much needed hand upon the conceptual integrity of that system.
A firm and that's needed hand, dude. He's one dude. We're putting a lot of weight on one guy. There's nobody ever noticing this. There's nothing else.
And that's what the chief decider makes.
Species. These guys are billion-dollar companies, and they can't come up with something better than this crap. Billions and billions of dollars. You can't find anyone. Wow, Linus is the only one, huh? Huh. Interesting. I wonder why. That is. They have billions of dollars and nobody can't find anybody competent to do anything anywhere close to it that one guy can do. And you're just resting. Well, we're just going to have a firm hand with that one guy. This is ridiculous.
He or she is the one that provides that conceptual integrity. And when that person is gone, then you naturally see drift. And that's inevitable. It's entropy. Software also.
It's called most stuff that we love and we got to use. We came from one person, and then that one person's vision lit up a light in other people's vision. So, but we don't have that. If we don't support those one vision people and really make national heroes out of them instead of throwing them away, you throw these people away like they're trash, and you wonder like, why haven't we seen more? Why have we seen more stuff happening? Why are there more people standing forward to get crushed and used and taken advantage of and stepped aside? Oh, Steve Jobs is the most. No, it was Woz. Steve Wozniak was the shit, man. Not Jobs. Jobs. There's a lot of guys like Jobs running around. Where there wasn't a lot of Wazas. We don't even remember that. Oh, he's just a guy that had some chips and stuff. No, he's a freaking genius. He's a natural hero. Should be put. He should be take down the Washington Monument, put the Woz Monument up while he's still alive. But no, I don't want to hear that.
Software exhibits some degrees of entropy. Without adding that kind of force to it.
One thing that is very relevant today in terms of technologies and architecture is AI. This technology is here. It's revolutionary. It is disruptive. Now, you've been in the industry.
It's revolutionary. We also got to look at the Liza effect. These guys are hyping this shit up way too much. This was December. This was about a month ago. So they're still hyping the wave. It's like, hey, look, man. If it was anywhere close to what they said it should be here by now. They should be using their own AI tools to create these tools to ramp it up and be here by now. What? They got billions of dollars in servers and all this technology. Think they can take over computer programming? They should have done it by now. And the fact that they can't means they won't. Not with this shit. It'll be something else, maybe, but I don't even doubt that because to get the insights, to have the machine write the code, you got to be a person. I know. Why don't you do that?
For closer to 50 years. If you look back, how do LLMs and AI compare to the industry to past innovations and events? Because for many of us in the industry, for those of us who've been for over 20, 30 years or so.
They said the same shit about, because I was there, the same shit about them that they're just saying about it now. It's going to replace all the programmers. Like, no, it's not.
LLMs do seem like the biggest change of software.
Yes, they're really useful, super great. I'm better than going to fucking Stack Overflow being verbally abused for asking a question. That's a repeat. That's a repeat question in the comments section. You're just, you idiot, you dumbass. How could you even think of using the 2xy instead of the 2x2? What's wrong with you? Totally abusive. Yes, we needed something to take care of that. And yes, these LLMs are pretty good at that stuff. That's right. But they're not going to do engineering, dude. If they were, we'd already be seeing it by now. It's been 2 years. We'd already be seeing it because they boot their tools up. They would start writing these things way better than anything. It was self-reinforced, but they can't do that. But they want to. They're trying to, but they're not there. I don't think they ever will be because that's not how humans work. Even with the trillions and billions and billions of keywords, it's still not even close to what we're made of. And where we live in our world, we get trillions of times a second. We get a ton of that per second a year. And that's just one person. Like, multiply that by everybody in the world. Come on now, stop. And they're like, no, we're going to have some tools that totally take over the job. We're not out of work. No, we're not.
But when you look back, have you seen something that was comparable in terms of impact or the pace of change?
Yes, they said it all the time. They had all kinds of shit that said it was going to be, they had expert systems, they had this UML diagram, they had super simplified languages, and they all went nowhere. Well, they did. They started taking off. It was like, oh, we can't have this, and we're killed by the product. These companies kill them off. Because, like, no, we're not going to let this low-hanging fruit go where we can put everybody in these walled gardens and charge them subscription fees. We're not going to do that. We got to do that first. And then when this AI thing gets out of the bag or whatever, then maybe we'll allow the people to have it. And that's going to be a totally different thing by then. Yes, they've said this a bunch.
That's a great question.
They didn't even COBOL. They said COBOL. Now that COBOL is here, we got the perfect language. It's just English words. And look at the IRS. The IRS runs on that stuff, and they can't fix it. They can't change it. They can't modify it. All the people are dying off. Not just fired and pushed out, but dying off. They don't know how the stuff works. The AI is super confused.
Yeah. The first, I think, was just the realization that I could build distributed systems as opposed to putting all my processing on one. That's
been around forever, man. All the different banks and all the different accounting stuff, they would send stuff back and forth. This has been around forever. Now stop.
That was a change that rattled everything in the way we built systems. So the point in time.
We've been doing that for the interoffice memos. One team is doing the calculation. Come on, man. We're doing this forever. This is nothing new. Stop. You're too focused in on the like what the little machines are doing. I guess you grew up at a time when they weren't networked together. Or you wouldn't get into it early or something. I don't know. But it's like, no, man. We've been thinking about this stuff for a long time. Stop.
Time that all of a sudden I could have.
I mean, Alan Kay has he just explains it fully how all this stuff operates. It's not very difficult, but to blend it in with the current crap, to shoehorn stuff that we have in it into that style, no, they're incompatible things. You got to completely break from the old way and do a whole new thing, which is still gonna happen. It's gonna happen at some point because this is the way these things and machines are set up right now. The Linux kernel,
A network of mini computers. And then eventually that carried on to microcomputers and devices at the edge, like phones themselves. But that transition in the growth of mini computers was seismic.
The edge? What are you talking about? I mean, a local cache server that runs it with the ISP? What are you talking about, dude?
That I don't think people understood the full implications of until much later, because it required us to rethink the way that we put systems together.
Oh my God. Instead of on one machine at one location, you have a couple machines, a couple locations. One does one thing, one does another thing. Dude, it's they overcomplicate the shit out of this stuff. Look at my video about how to, universal architectural system. This isn't he's overcomplicate. He's got to make it be an IBM fellow, right? He's got to be an IBM fellow, so he's got to overcomplicate stuff. It's like, dude, stop overcomplicating things and obfuscating and gish galloping. It's annoying.
So we saw there the rise of a great degree of uncertainty because we didn't know how to build these systems. I have messaging across.
Oh my
them
God! Yes, what are you talking about? From the monolith to the thing? Come on.
So RPC? Do I use something else? What do I use to communicate? Do I use
RPC? See, a remote procedure call? Okay. I mean, aren't they all just remote? It's like sending a command over to a thing. Give me that piece of data. Bring it back. Or do this command. Change that data. Or crud. Really, dude.
shared memory. And so there was this period of exploration that we didn't know about until we realized, oh, these are the common ways that work.
And
oh my God, they were gonna find him anyway. I mean, people figured them out anyway. You weren't special, guy. I mean, he tries to make himself like he's this pioneer. It's like, dude, they were doing this shit for a long, long time, buddy.
remind me around what time this was? Was this around the 80s? Was it around the 90s?
There was the late 70s because here you had.
And they were doing all this shit in the 40s and 50s. When they first got these machines up and running, that's the first thing they did is send data between them. What are you talking about?
Let's go back way in history. There was the thing called, gosh, what's the name of it? I'm drawing a bit of a blank here. But here we are in the late 60s, early 70s, in which mainframes were roaming the earth. But even then, it was
roaming the earth. No, they're all mainframes. That's all we had. That's all we used. That's what was available. That's how the systems work. They're all batch oriented, roaming the earth like they were dinosaurs. Come on, man.
There's a realization that these machines were sometimes being underutilized, and so there was born.
Sometimes being underutilized. Yeah. Yeah, you had to have human operators to load the programs and stuff. Yeah, of course they were underutilized. They hadn't changed since the 40s when they were put together, and they were happy to have them adding up numbers efficiently instead of having to have somebody type them into a calculator a dozen times. These guys. Grady.
The formation of the first time-sharing systems. The next thing that happened around the same time were systems such as Whirlwind, which came out of the Lincoln Laboratories, which was beginning to take machines and touch them to the real world. So all of a sudden now you had real-time computing. So you had this confluence of two very interesting things. You had large machines in which we were beginning to develop time-sharing kinds of operating systems, and then machines off to the side that were touching the real world. These came together in really
the real
rise
world.
of mini computers, particular Digital Equipment Corporation and the like, where miniaturization, which frankly came about because of the investment the Department of Defense was making in semiconductors,
turn into missile defense. Yeah, they had to miniaturize it. Yes. And you're lucky you got those breakthroughs. You were lucky because it took a long time because nobody knew how to do any of that stuff for a long time.
Making it economically interesting to have a computer that could sit on your desktop that one or two people could use full time. So it took kind of the ideas of the embodiment of things like Whirlwind and then the distributed systems we were people building. Now all of a sudden I could take these things and I could start building them together. And that's what was happening in the mid to late 70s that we saw the rise of those distributed systems. There was one last thing. There was the rise of client server systems where you saw dumb terminals. That's what IBM was doing at the time, the green screens, talking to mainframes. But
the green screens, teleterminals, like terminals. I don't know, man. This stuff was going on way before all this stuff was happening. So, like, it just wasn't, I guess, wasn't well known. You'd think that these academics would be talking to each other and going to these businesses and finding out how they're doing stuff, but most of the stuff is proprietary. Anyway, let's keep
The rise of those new machines meant I could move some of the processing off to the edge as opposed to leaving it in the monolith. So those are the forces that led us to rethinking.
What is he talking about? Edge and monolith. What is he talking about, man? He just runs off the mouth and like, what? You have to find some of this stuff it means, man, because you're using these terms very loosely and very like flippantly, and you're switching definitions left and right. Did you not? This is the guy. He's a leader of thought. Okay, whatever. Let's keep going.
So do I understand correctly that programmers at the time, they were used to working on these large computers, and distributed computing came in?
Absolutely.
And it just completely changed.
Yeah, because before then you had to have a key to get into the computer room to run your own things, or you had to put your stack of paper tape, punch tape cards into a mail slot, and it got picked up in a week or so. Oh, you mean now I can type my program in it myself and then run it interactively? Yeah, it's gonna totally change the whole damn thing. Instead of taking a week, it takes a few minutes or a few seconds, sir. It just happened. No, it was like, dude, that suck having to type the cards out, and and then you give it to the people, and then a week later, that was not good. That was definitely unsustainable. It did employ a lot of people though, but as soon as the timeshare stuff came on, all those people jobs.
Change the dynamics. So youngsters came in, they started to embrace this distributed computing, but existing programmers, they kind of stick to what they knew was efficient on the mainframe. Was that what it was like?
It was. And then when you had things like TCP/IP and HTML.
Well, there was one that was access control, then one was just not access control. There was a movement, and the not access control was the timeshare stuff to get kids involved because they could go there. They were safe. A distant location was just a terminal to the mainframe. They weren't anywhere near the damn room. Calm down, Seymour. You didn't have anybody come in your room. And you could block these into a little sandbox. So yes, and they encouraged lots of kids to get involved with that at that time. Because guess who wasn't encouraging kids? The guys at the computer room who had the key. I'm not gonna let anybody. I learned my way to the top. I had to learn my way to get this key. Like the goddamn founder of Unix. He was given a key so he could access this thing at night when nobody was working on it, and they left the machine on because turning it on and off caused the machine to wear out sooner. It's like great. It's like yes, that was bound to be just that system was only had a very brief moment where it was possible, and then it was like, so.
And all those things around it. All of a sudden, we now
that attitude, that gatekeeping attitude, still exists. He's holding it. This guy right here is one of the gatekeepers, by the way. Just put it out there.
Had a vocabulary. We now had mechanisms that we could bind these things together. So I would not say that LLMs are as pervasively as important as the rise of distributed systems, but there's a parallel to it. The second thing I'd say that is.
You mean on a network? You mean not having all the stuff on one machine, one location, having it all over the place? Come on, man. This is the IBM fellow. This is his amazing insights.
Sort of similar to that is the rise of GPUs, which came from the gaming industry, because there they were solving a very different problem. How do I deal with more photorealistic things in my games? And we realized it's all matrix multiplications. And so NVIDIA began to move into that marketplace, and we had the rise of GPUs, which dominated that space. And it wasn't until Andrew Ng came and said, wait a minute, those GPUs used for gaming use the same kind of mathematics as do our deep learning kind of things. And poof, all of a sudden we had this perfect storm of lots of data, powerful hardware, and the rise of interesting algorithms, backpropagation and the like. So it was a perfect storm. So yes, this is an exciting time. There's no doubt that large language models.
I mean, it's useful. The stuff is useful. It's a step ahead, but it's not going to be this replace all programmers bullshit.
Are interesting, but we must be careful, and we'll go into that in a moment.
So let's go into that. I'd love to hear your candid thoughts about LLMs, their applicability, the innovation, and the trade-offs that they come with.
Well, so to set the stage before people worry that I'm just pontificating about things I know nothing about.
Yeah, you like to do that too, sir.
I alluded to it at the
I'm glad you have that self-awareness that you do that.
very beginning, that in here I was 12, 14, whatever. I was interested in what was burgeoning, becoming AI at the time. That has always kind of stuck with me. And in what would have been
maybe expert systems, just a tree, just not a decision tree. Come on, man.
I've always pursued an interest in that space, and it wasn't until IBM drew me back to it around the time of Watson that I began to make it a full-time thing. So David Ferrucci, who led the development of Watson, had called me in and said, hey Grady, I'm going to give this lecture, I can't do it, would you do it for me? And I said, David, happy to do so, but only on the condition that I can choose the topic. And the topic I chose is, what is the architecture of Watson Jeopardy? And as it turns out, nobody documented it. So being an
Well, that's a shock.
expert in the architecture space, I sat down with David's team for several months and documented the as-built architecture of Watson Jeopardy. It's not a neural network system. It turns out to be a pipeline architecture that, through a pipeline, brought together a number of statistical systems. AI at the time was all about predictive statistical methods.
What is it now, sir? What are you talking about, Booch? It's the same shit. Stop.
Not neural networks. And
oh, hey, come on, man. It's all the same stuff. You're making it sound like these are different things. It's all the same shit, man. A predictive statistical model. What do you think a neural network is, dude? Am I there? I'm not an IBM fellow. I barely graduated college, and I know what these differences are. This is where I get my. What are you doing, dude? What are you talking about, man?
And methods in knowledge engineering. And so I documented the architecture. That
Knowledge engineering, is that really okay? That's a new thing. This time I've heard knowledge engineering. What are you talking about, man? You talking about library science, like kind of catalog stuff? What are you talking about?
caught the eye of IBM management, and it's for the first time I really documented an AI architecture.
And
so IBM,
for those of us who don't know, this What's in Jeopardy. This was
It's a machine language statistical, not artificial intelligence. It's not the sci-fi shit we saw in 2001. Hal opened the bare doors. It's not that, dude.
the IBM computer that played the game Jeopardy and won, if I remember.
It won. Yeah, we beat all the humans in that space.
And at the time, this was in mainstream media, in the press, everywhere, and this was shown as an example of an AI system that can outperform a human on a very human task, which is this.
It's not a human task. Remembering random facts, trivia, definitely a computer task. Humans are terrible at this. That's why they have them on a game show where they win big money prizes, because it's not a human thing. It's definitely a machine indexing, library sciencing thing. See, this is where guys like take the practical engineer here. You got to get out of the sci-fi world, man. Be back down to reality, back down to what actually is real, what they can actually demonstrate, which ain't much.
Show Jeopardy.
Yeah, right. And it was part of the trajectory IBM had been on in that space, because before that we had Deep Blue, which beat the leading chess player at the time.
Okay, that's not that impressive, guy. That's now for humans it is, but for the machines it was just a horsepower thing. It's just a number of matrices that could check to see whether this move is better than that move.
Gary Kasparov, yeah. So we did that. Yeah, we did that through brute force.
Chess is not a human thing. That's why humans have a hard time with it. It's not a human game. It's a machine game. It's got a set of constraints, rules, blah, blah, blah. It's not a human thing. That's why we're super impressed when we see these things do work this up, because it's all this mechanical, statistical calculation shit, which humans suck at.
Brute force methods. Then Watson Jeopardy came along, beating humans in natural language processing at the time. IBM had already been doing things in that space with a system, again, statistical systems. We eventually sold it to Nuance and the like, but we were pretty dominant.
No, doesn't affect any of this stuff though, right?
In the space of natural language processing, and IBM Watson Jeopardy was the peak of that. So IBM asked me, "Hey Grady, this is cool stuff. We're going to commercialize this. Would you please, help us do a study as to what IBM should do with this?" So I led a study for about a year in cognitive systems. What should IBM do? Now this was interesting because I studied what Watson was doing. I looked at what was happening in the marketplace. Here we were, 2010ish or thereabouts, a little bit later. It was that decade, and I made it very clear to IBM management, this is pretty cool, but be careful because there are things we know it can't do. And I was very clear to our management that be careful about hyping it. Well, I remember in my meeting with Jenny, when I was doing the briefing about the project, Jenny was the CEO at the time. She asked me a question. One of the VPs stepped in and started talking over me and said, "Well, yada yada." And I politely said to him, "Well, thank you, but I think you're wrong." And I went on to explain to him. Now, if I were not
okay, credit. Give him some credit here. He's trying to reduce the hype wave, because all the guys see is dollar signs. VPs are like, "I'm getting my bonus. I'm gonna go do much more cocaine off a stripper's ass for this Christmas. I need to get this AI hyped up."
Not a fellow, I'm sure I would have been fired on the spot. But as a fellow, I got to say things like that. Now, they did not invite me to join the Watson group, so I was happy with that. So I worked off on the side. But it's sort of an "I told you so." That there were things that we can't do, and by God, we can't do them. So I was working in the underground for several years, and I'll get to the answer to your question in a moment, but it explains why I can say something meaningful. So I was kind of an outsider. I was kind of doing my own thing inside IBM, and then we had a team down in Austin who had been approached by Hilton Hotels, who said, "We'd like to build a robotic concierge for our hotels." And so we chose some robot.
So we can get rid of people. We've already got these things in China and stuff, so we can just get rid of people. Get rid of those fucking people.
That's from Aldebaran, a company out of south of France. They built these 3-foot-tall robots called Pepper and smaller ones called Neo. And they built a robotic system, which was kind of cool. It was a question and answering system based on Watson technology, but there was something missing out of it. And the team came to me and said,
"Yeah, humans."
"Grady, would you please help us out?" So I did. I helped improve the architecture. We actually installed it in a few Hilton hotels. But as it turns out, just down the road from that team was the Johnson Space Center. And so we began to be involved with them. And I thought, this is all great because I can get back to my space roots. So they had a system called the Robonaut 2, which was
low Earth orbit. Let's be realistic. It's not space. It's low Earth orbit. Okay.
Was a humanoid robot that at the time was on the International Space Station. A beautiful piece of engineering. And NASA was exploring the idea of human robotic interactions for the mission to Mars. So the group of us set down.
How about a mission to the moon? No? No? How about putting some bases up there? We're going to Mars first. All right, Booch.
And said, what would be an interesting design problem for us to explore that would propel us to look at hard problems? Because we want to do hard things. And we realized it was the mission to Mars because it had two interesting use cases. The first is, because of the speed of light issues, you couldn't rely upon mission control on the ground. You had to take it with you. This was
Oh my God.
the HAL problem. We needed to build a HAL minus the kill all the humans, which use case.
Oh my God. Booch. Booch.
Which for some reason NASA didn't want that use case. I don't know. It's their choice. The second is, at the time, NASA wanted to put robots on the surface of Mars to help astronauts, build their scientific experiments and build their habitats and the like. So I remember one after.
They're not going to come from NASA or IBM, this crap. This is going to come from someplace else. This stuff is not practical. They've been trying this shit for fucking decades. They're not even close.
Afternoon.
But we're going to bring us IBM buying robots. Mars. Get out of here. You can't even do that stuff on Earth. You're going to do it on Mars? And you're going to base the survival of humans on this stuff? Come on, man.
I sat down and said, I know how to architect this. This would have been around
2014. He knows how to
2014.
architect it. Oh, he can architect it. Oh, I'm so grateful that Booch can get a robot on Mars. He's got the architecture. Look at this guy.
And I built a neurosymbolic architecture we called Self, and it used the idea.
Demonstrate it. Demonstrate it. Demonstrate any of this. Any of this exists. Does it actually work? Has anybody else tried it? Or is this your story of it? This stuff is so specious. Booch. Booch, you better have all this stuff documented someplace. Have a YouTube channel showing how all this stuff works. No? Doesn't exist? Oh, okay.
Ideas of
More
Marvin
bullshit.
Society of Mind.
Oh,
together
okay.
with Rod-
Wow. More bullshit coming out of IBM. Wow. What an amazing accomplishment of mankind you have done here, Booch.
Brooks's notion of subsumption architectures, together with
Subsumption architectures? What the fuck are you talking about, buddy? Do you demonstrate any of this technology doing anything at all other than you blabbing about it and making companies, signing up companies for your specious stuff? You got a good grift going, man. I respect the grift. I respect the grift. I respect the grind. He's got a book. Ooh, he's so smart. You got a bookshop back. This stuff is so specious. This stuff is so crazy. Like, you need to demonstrate all of these claims. And if not, this is just, you can just write this guy off. Like, man, whatever else comes out of his mouth, it's going to be specious and need to be checked, double checked, triple checked, in duplicate, independently. Not IBM hype sheet. VP of engineering wants to get his bonus this week so he can do cocaine off a stripper's ass during over Christmas break.
Hofstadter's ideas of strange loops, and those three.
Oh my God. Strange loops. Strange attractors. Chaos. Math. Ooh, could you put some more buzzwords in there, Booch?
Came together forming the Self architecture, which we then.
The Self architecture? What is this? See, I'm pausing it just something like he's like, because he gishgouts this stuff so hard, and this stuff is all specious. It makes it seem like this stuff is all done deal, fixed up, buttoned up, put in a little bow, and off ready to go.
Built. And so we experimented with NASA for a while to build some software behind the Robonaut 2. Do things
with NASA? You're with NASA? Who are you with NASA with? What part of NASA? What is NASA? Who in NASA? They came and launched their own rockets. What are you talking about, man?
Things like, hey, robot, here is a scientific process. Go do this, or go clean
Booch, are you serious right now?
These filters, which is a common.
Booch, a robot to go clean filters? You're serious about this?
Station keeping activity. So we were actually building the software that allowed humans to interact with it and also serve as question answering things.
Were you building it? Did you finish it? Did you get it finished? Can we see it? Can we play with it? Can we describe? Can we verify any of your fucking claims?
That led us to Soul Machines, a company out of New Zealand.
Soul Machines. Oh yeah, that doesn't sound sci-fi and hyped up, overhyped, under delivered, over promised, boondoggle to get a stock pump price. No, never heard of it. This is not the most common thing in tech now. This is lying about technology, the sci-fi stuff that they stream on Netflix. And it was like, oh no, this exists. Oh my God, we're right around the corner. It's the new UML. We're going to Mars.
They were an offshoot of the work that John Cameron had done in the movie Shoot, what's the one
Oh,
he's
a
done? He's done a
movie.
trilogy of them now. That he had this great technology where you put cameras on the artist and it would measure their muscle movements. They
Oh my God. Are you fucking serious? Green screen motion tracking? Really? How does this have to do with people getting to Mars?
took that, they built a neural model of human musculature, and they had the
They built a neural model of human musculature. A neural model, huh? Wow, NASA.
great hardware
Huh.
for it, but they had no software, so we helped them in that regard. We then also worked with
And then they have no software. Oh, really? Can you show us this? Can you demonstrate any of this stuff? Nope. Just skip it off to the next thing. We're making movies now. Before that, we were on Mars with robots, changing filters. Now we're making movies with James Cameron.
a company called Woodside, an oil and gas company out of Australia, because they had a problem similar
Oh, now we're pumping oil and gas. This
to,
guy gets
to
around,
NASA.
man.
They were building systems for oil rigs, which is a very dangerous environment. And so they wanted to build cooperative robots, just like NASA was doing. So here we were with a system called
He's like, yep, that's right. That's what they want to do. Do you demonstrate any of this stuff? Can you show it? This is a lot of work. This is lifetimes of work. Just one of these problems is lifetimes of work. And he's just skipping around. Yep, we almost got this finished. Like, it's almost a done deal. Almost in the bag.
itself. It was, frankly, a neural symbolic system. It had neural pieces, but also symbolic pieces based upon
It's a neural and symbolic. Oh, they got neural pieces. And you guys got neural. What the fuck is a neural piece? What the fuck is a symbolic piece? Just gish crap along. Oh, making movies. We're going to Mars. Playing with robots. Change filters.
those three architectural decisions. It was pretty cool. At its peak, I had
Who is
35
this
people working on this.
guy?
But then we recognized IBM was
Well, there's 35 people at the peak. Oh, well, that's good to know. It's 35 people. Okay. What does that have to do with anything? Can you demonstrate any of this technology? No? It's all proprietary? Oh, okay.
across 6 laboratories, I should mention, around the
Oh,
world.
it's 6 laboratories. Oh, yeah, they should have this been wrapped up by now. They should have these things walking around changing filters everywhere right by now. Booch.
Which made it possible for me to live and work out of Maui, Hawaii, which is where I still am. But then IBM
Oh, so he's living the life in Hawaii. This guy. This guy.
recognized
He's
IBM
got it good, man. He got a good grift, man. Props. Props to the master grifter.
Watson was bleeding cash, so they fired everybody. And again, being a fellow, they didn't fire me. So I continued in that space. But
Yeah, so you continue on with your bullshit, unabated, just completely running amok, telling people all kinds of stuff. You fixed robots, you fixed the mission to Mars, you got that all complete, you got a symbolic processor, you got a neural engine on there, whatever the fuck that is.
that was my exposure to the first set of new kinds of architectures. For about 6 years now, I've been working with a set of neuroscientists to try to understand the architecture of the organic brain.
Oh my God, this again. Dude, autist, Mr. Autism. The brain is just a piece of hardware. The software that runs it, you ain't gonna find there, man. So I don't give a fuck how many times you dissect the brain open, and you're never gonna find the thing you're looking for because it doesn't exist there. Stop.
And so
These
rather
guys
than,
are crazy. They think the brain, just having this mush thing, is gonna give them the key to understand our consciousness and where it comes from. And they're never gonna figure it out because it doesn't come from in here. It comes from someplace else that we will never figure out, that we're actually not allowed to figure out. We will not be able to figure it out. You can take this thing apart like you're taking apart a radio set. Where's the band? Where's the rock and roll players? Where's the announcer? Where's the news station? Where is it? I took the thing apart, took the radio apart. Where is it? It doesn't come from there, ding dong. These guys, man.
software kinds of things, I've been studying things like cortical columns and the loops that exist in the hypothalamus.
Oh my God. So the physical structures, oh, you think you're going to figure out how the whole thing works where you can make a real, you think you can create a simulated human being just by studying the brain? Dude, these guys are insane. They have gotten so high on their own supply, and they really think that they got this thing figured out. And nobody's telling them no. I'm telling them no. No, Booch.
So I've been looking at architecture from the lens of a software architect into these kinds of organic systems. And so
You're never going to find it there, sir. By looking at the hardware of a radio receiver, transmitter, you're crazy, man. You think you're going to get you're thinking of finding the news reporter in there?
that now leads us finally back to your question.
No.
What do I think about large language models? The answer is they're pretty freaking cool. However,
Yes,
they are by the
useful.
very nature of their architecture unreliable narrators. That's what I say.
Yes, of course, just like humans are, by the way. This model that we're using LLMs, it is very similar to how we take things together, put things together. But you're never going to have all the neurons to simulate the computer, to simulate a human being. You're not going to be able to do it, man. You're not going to be able to do it, man. 54 minutes. Okay. I got the last 15 minutes. I'm gonna finish it up part 5. If you made it this far, you guys, you're feeling it. You're feeling what this guy's bringing. It's like a lot of bullshit, but he's also got some good things. But like a lot of like, hey man, you have to prove all that stuff. The age of us just believing you is over. Just you have to demonstrate all those claims, and that's where I have issues with these people. Is they have been claiming this shit forever, and it's just around the corner, but that just around the corner just never seems to come. Or they deliver something and it's just they fake the demo, or it's just this one case, or they gave them the answers ahead of time. All right, we're gonna finish up next time. Give me a like and subscribe. We'll talk to you soon.